Okay, so this is video number 19, and it is chapter 4, section 2, and it is all about graphing exponential functions. And the first thing I want to do is actually connect a keyboard and take you over to Desmos, where I just want to graph a couple of exponential functions. And these are the functions I'm going to graph. I'm going to graph f of x, or remember that means y, equals 2 to the x. I am going to graph f of x equals 4 to the x. These are going to be the parent functions that I'm going to start with. And f of x equals 6 to the x. And then let's come back and talk about similarities and differences in the Desmos graphs. All right, so bear with me here for a moment while I attach a keyboard. All right, so I think I have Desmos open already. Let me hide this little thing. I don't know why it's not switching off here for me. Okay, so here's Desmos. Let me get rid of all these guys. All right, so we're going to start by graphing. I don't even need to put the y equals. I could, but I don't need to. So I'll just go 2 raised to the x and take a note of a couple things that happen. One thing that happens is I want you to notice that this graph goes through the point 0, 1. Okay. Also notice that it is a curved function that never crosses the y-axis. So I'm just going to bring this out here for you just to show you it approaches but never actually crosses the y-axis. Okay. Oh, that's the x-axis, sorry. The other thing that happens is it also crosses not only this point right here, 0, 1, but it also crosses the point 1, 2. So I could put a point on this graph, the point 1, 2 is on that graph, okay? So let's take another look at 4 raised to the x power, 4 raised to the x. There's another graph, that's the blue one. Again, please note that it goes through the point 0, 1, right? This guy right here. And take a look at what happens where x is 1. What happens where x is 1? Well, it actually hits 1, 4. So that's interesting that the graph of 4 to the x hits 1, 4. The graph of 2 to the x hits 1, 2. Well, let's see what happens when I graph 6 raised to the x power. Again, note that it goes through the point 0, 1. And also note that it goes through the point 1, 6. Okay, so if I were to plot the point 1, 6, it's going to fall on that graph. Well, what do you think would happen if I scroll down here a little bit? If I were to plot the graph 12 raised to the xth power, do you think if I were to pre-plot the point 1, 12 there, if I were to graph 12 to the xth power, would my curve hit that point? And would it also go through the point 0, 1? I'm going to guess, based on the first 3 that I did, that it is going to do that. So let's plot that. 12 raised to the x. And you can see that it does indeed go through 0, 1. And it also goes directly through that point that we have there. So these are all curved functions, right? And these are all positive, right? Those are the parent functions that look like that. So we're going to kind of use this idea to make some generalities about the graph and then give you some basic rules and then come and see how they work out. Okay, so let's go back to here. I'm going to pull my keyboard off. Sorry if this is loud when I do that. All right, so some similarities is that all graphs pass through the point 0, 1. And this guy is called the base, right? So these functions are in the form a to the x, where a is the base. And so another kind of similarity I want to state is all graphs pass through the point 0, 1, and also the point 1, comma a, right? This graph passed through the point 1, comma 6. This graph passed through the point 1, comma 4. This graph passed through the point 1, comma 2. When I did f of x equals 12 to the x, that passed through the point 1, comma 12. Remember, I pre-plotted that point and it passed through there. Okay? So that is the similarities. What else? None cross the x-axis. So the x-axis is what's called an asymptote. asymptote, which means the graph doesn't cross it. Okay. All right. So taking that one step further, let's flip to a new screen. And if we have this in the form f of x equals a to the x plus c plus or minus b. Well, let's just say plus b. All right, here are some rules for transformations. Excuse me. Of exponential functions. Okay, here's the first one. One. If a is negative, then the graph is reflected about the x-axis. Okay, so a little picture real fast. If here's a graph and here's a graph, and we're talking about 2 to the x, then that's going to go through here. It would go through here and here. That would be that graph, right? Well, the a being negative would mean I have a negative 2 to the x. Being reflected over the x-axis means this point would now be negative 1, and I'm going to also come out to up to 2 and over to negative 1, and this is going to come this way. So that's what that would look like. The a value, the base, would become negative. Okay, rule number 2. If the b shifts the graph vertically in the direction of the sign. Which means positive makes it go up. And negative goes down. Actually, that's a big old set of parentheses. Okay, so let's do a little picture to see what that would look like. So if we had normally, let's say we normally have, again, 2 to the x, that's going to be a point here, and then 2 and 1, so that would be this guy. Okay, well now the b is over there, so this is going to be 2 to the x, let's say, minus 3. Well, vertically is up and down, right? So this is going to shift this down 3 units. And so when you do this, if this point is normally, and by this, let's see, I'll do this in blue. This point on this graph is normally 0, 1. I'm going to take that down 3 units, literally. So if that's normally 0, 1, I'm going to go 1, 2, 3. And that point is now going to be 0, negative 2. And then this point right here is normally 1, 2. It's still going to be at 1, but I'm going to drop it 3 units. So it's going to be at 1, negative 1. It's going to come here. And my asymptote is going to be 1 unit below this guy. So it's going to kind of come. Oops, I missed my point, but you get the idea. So the graph is going to look identical to the other one, just 3 units lower. Okay. If this was a plus 3, this whole graph would have shifted 1, 2, 3. And it would have gone, this point would have gone up. Oh, I would have to go up even another one. This point will go up 1, 2, 3. And then my next point would be up 1 over 1. And that whole thing would look like that. Okay? So that's the idea with that. All right. The next point, number 3, the C value. Shifts the graph horizontally opposite the direction of the sign. Okay, so that means if it's positive, it's going to move left, which is normally the negative direction. And if it's negative, it's going to move right. Okay, so that's what those guys mean. And here's what this means. It might even be easier to see this on the same coordinate plane. Let's go. 1, 2, 3. Okay, so if I do 2 to the x, which we know sits here and here, that would be the parent function. And then if we take and do 2, now look back at the original. So we're talking about this up in here, x plus c. So this is up in the exponent. And let's go x minus 2 up in the exponent. So now a negative is going to move this. So this is going to move 2 units to the right, opposite the direction of the sign. So normally a negative 2 would be moving to the left on a graph. You're going to go the opposite direction. So we're going to take these points and we're just going to shift them 2 units. So I'm going to take this first point at 0, 1, and I'm going to shift it over 2 units. And I'm going to take this point and shift it over 2 units. And this is still going to approach the y-axis. And that purple graph would match that purple graph. Okay, so let's take a look at the notes here. I've got the C, I've got the B, I've got this. All right. If the exponent is negative, so this is interesting. This is the next guy. 4. If the exponent is negative, the graph is reflected about the y-axis. And I thought this was really interesting when I looked in my textbook, and then I thought, something else actually happens. So I just want to remind you rules of negative exponents. There's a rule in exponents that says a to the negative m is equal to 1 over a to the m. So let's think about this in terms of exponents. If I have 2 to the negative x, and I apply this rule right here, well, what does that do to this guy? It makes us have 1 over 2 to the positive x power, which is really this. You're taking this x and applying it to both of these, because 1 raised to any power is still 1, and you're raising the 2 to the x power. So this 2 to the negative x and 1/2 x are exactly the same thing. So here, this is interesting. Very interesting. Okay. So I have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 2, regularly 2 to the x. We know that that is, I'll do this in green, 2 to the x. 1, 2, and that goes this way. Okay, so this statement says if the exponent is negative, the graph is reflected about the y-axis. Well, that means that this point right here is shifted across the y-axis. So it would go over here. Let me do that in a different color. It would go over here. This point is still the same, and this graph would be this guy, 2 to the negative x. That would be the reflection. Well, this is also this graph because of the rules of negative exponents. So this blue graph right here, the blue graph is 2 to the negative x is exactly the same as 1/2 to the positive x. These are the same. And in varsity, you're going to see mostly this. I didn't see any negative exponents, I don't think, when I did the varsity assignment for this. So just keep those in mind, and that is why that's going to happen. Okay? So that guy's there. All right, here's something else you need to know. I'll do this in green. I'm going to extend my page a little bit more. This is rule number 5. Now remember, our original function was f of x equals a to the x plus c plus b. So this is referring, just to remind you that that's what that looks like. A coefficient, remember that's a number in front of the graph, in front of a, will do one of two things. It will stretch it if a is greater than 1, or it will compress the graph if a is less than 1. Okay? And then here's a couple of rules about reflections Then I want to take you over to varsity and show you a couple of ways, at least how I go about doing a transformation when I have them. So actually, let me go to a new page. So some rules, just two real quick rules about reflections. If you have a hard time actually seeing a reflection and need a rule, if you have a flip about the x-axis, then any point you have on the original graph becomes the point A negative B when you want to do that reflection. And so you'll see that when well, let me just do an example. If we want to, let's see, reflect the graph of f of x equals 4 to the x about the x-axis. Okay, so we'll just make a real quick graph right here. 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so the normal graph, the parent graph here, I'll do that in green, and then I'll do the reflection in red. Okay, so 4 to the x, we know that that's going to go through this point, and then 1, 2, 3, 4. So this is the parent graph. And so I have these points, 0, 1, and 1, 4. And so to do the reflection, I take these points and I just make the B part negative. So I'm going to have 1, negative 4, and 0, negative 1. And so now if I plot those, I have 0, negative 1, and 1, negative 4, 1, 2, 3, 4. And we know that the x-axis is a asymptote. So this graph, the reflection of this would look like that. And that's one way that you can do that. Or if you can see, you're just going to drag them equidistant. So this is 1 unit away. So you're going to go 1 unit away. And this is 1, 2, 3, 4 units away. So you go 1, 2, 3, 4 units away. So you just drag it to the x-axis and then the opposite distance on the other side. But if you like the rules and you don't want to do it visually, that's a way that you can do that. Okay? So here's a rule for flipping it about the y-axis. Let's extend the page. All right, so if you're going to flip about the y-axis, then any ordered pair AB will become the point negative A, B in the reflection. Okay, so again, if I have the same function, we'll use f of x equals 4 to the x. And we'll do so we know that we have the point 0, 1, and then 1, 4. And that's the normal one. This is f of x equals 4 to the x. We already know these points are 1, 4 and 0, 1. So now what we're going to do is we'll do the reflection in green. We're going to take the point AB, 1, 4, and we're going to negate the A. So we're going to make this negative 1 and keep the B the same. You can't make a 0 negative, so that point isn't going to change at all. So this point's going to be 0, 1 and negative 1, 4. And this takes and flips this graph this way. Okay, so those are some rules that you can use for those reflections. All right, so I am going to, I don't know if I actually need a keyboard for this, if I can just use my mouse. So I want to navigate around a little bit and show you kind of how varsity is going to work. Let's take you out there. Okay, hide that. Go back out here. Let's go back to varsity. Okay, so let's just kind of go and take a look at some of these problems. So this just says, start with a graph of 2 to the x, write a function that results in the given transformation, and they want you to shift it 3 units downward. So going back to the notes, if we go back to this idea, we're looking at, they've already got the y equals or the f of x equals. We can shift something up or down, vertical, looking at the green here. The B shifts the graph up or down. So if we want to go 3 units down, we want to just put a -3 after the whatever the base is to the x power. So let's go back and do that. So I'm just going to go g of x is, I'm going to use the base function 2 to the x. Oh, see, I do want a keyboard attached. All right. Give me a moment. A lot easier if I have this keyboard stuck on here to navigate around. All right, so we're going to go 2 to the x, 2 raised to the x power, 2 raised to the x, and then make sure you get out of the x, and I want to go -3. Okay, so that tells me I want to go 3 units down, and I'm going to submit. Okay, so these are the first couple questions, first maybe 6 or 7 actually. All right, here, take 3 to the x and reflect it about the y-axis. So how do you do that? Well, you reflect something about the y-axis by making the exponent negative. So this would just be 3 to the negative x. 3 raised to, oops, I need to the caret, raised to the negative x. If I'm going to answer that, let's see if that's correct. This will be pretty embarrassing if I get these wrong. It happens. All right, so that's how those things are going to happen. All right, now graphing. Graph the exponential function, 3 to the x. So it's already chosen. I'm just going to plot 2 points. I know it's going to go through 0, 1, and I know it's going to go through 1, 3. Submit. All right, that's all you're going to do for that. Now, what about down here? Graph the reflection about the y-axis. Now, read this carefully. Graph the reflection about the y-axis. Now, here's how I would do this. First, I'm going to graph this. Remember the 1/5 raised to the x? And I mentioned to you that's going to be the one that's kind of backwards, right? So this is going to be like 5 to the negative x, which would be through here and through 5. Now, what they want is a reflection about the y-axis. So once you plot this, you can come back and get these, right? You have a pencil. If you click somewhere else, you're going to make a point. But if you get this 4-way white arrow, you can click and drag these dots. So I'm going to click and drag and move that over there. And that's a reflection about the y-axis. And I'm going to hit submit. And there's that graph. Okay. So this is what I really wanted to show you over here, of these reflections. How about this guy? Graph the reflection about the x-axis. Well, first I'm going to graph the function. Okay, I can't actually graph 4 to the x because they don't even have a 4 on here. All right, so I know I'd go through 1 and through 1, 4. So I'm going to go -1 and -4. All right, let's jump down here to 16 because these ones get a little bit more difficult. All right, graph the function that's a result of reflecting 1/2 x about both the x and y. So I'm going to start by graphing 1/2 x. Well, I know that that's that. Now, I'm going to flip it about first the x, and I'm going to do that by changing it. I'm going to drop these down below the x-axis, right? So I'm going to pull this down to here, and this guy down to -1, -2. Now that's flipped about the x. Now I'm going to flip this guy over the y. Okay, so I flipped it first about the x, then about the y, and I'm going to submit that. Okay, and that's how you're going to go about doing that. Now, there were a couple other of these. Here we go. Okay, so graph the reflection about the x-axis, 3 to the x minus 1. Now remember, if the exponent is affected by this plus or minus up in here, that goes in the opposite direction. So this would be 3 to the x. So I'm going to start with that. So I'm going to start with 3 to the x, which would normally be that, right? Now this minus 1 is going to shift the whole graph, right, horizontally in the opposite direction. So it's going to shift the whole graph 1 unit to the right. So this is going to go, each of these are going to go 1 unit to the right. Okay. Now I have to shift it about the x-axis. So these are both going to pop down to the negative values. So -3. Ooh. Okay. Hopefully that's correct. All right. So there you go. Okay. So that's how those are working. All right, so I'm going to jump back to the actual notes. So there is that whole video. Hopefully you have all of the information that you need. And remember, this is just about graphing exponential functions. All right, and then down here in the corner, don't forget that this is 4.2. Okay, toodaloo.